A very pleasant day to you, Engineer John. Me and my fellow group mates, Aidan de Guzman, myself, Christian Joseph Tuiza, and Richmond Vigilia are going to present or discuss about our dipole antenna design. So before we proceed, we have to know about the dipole antenna. A dipole antenna consists of the boom, reflector, the driven element, and a director. A dipole antenna can consist of several directors, but ours only have one. The first step is finding the center frequency. Before that, we have an assigned frequency of 54 MHz to 216 MHz. In finding the center frequency, the formula used is the square root of the minimum frequency multiplied to the maximum frequency. As I said earlier, our minimum frequency is 54 MHz and our maximum frequency is 216 MHz. As a result of 108 MHz for the center frequency. Next is finding the wavelength. In finding the wavelength, we just have to divide the center of frequency, the speed of light over the center frequency. The speed of light is a constant of 3 times 10 raised to 8 meters per second over our center frequency of 108 times 10 raised to 6 Hz is equal to 2.7777777778 meters. After that, we have to find the length of the driven element. In finding the length of the driven element, we have to divide the lambda or the wavelength over 2. So our wavelength is 2.777778 meters over 2 as a result of 1.388888889 meters.
To find the length of our director, we need to multiply 0.95 times the LDE, which is driven element. So 0.95 times 1.388888889 meters, and the answer is 1.319444444 meters. Next is the length of reflector. You need to times the 1.05 times the LDE, which is length of the director. So 1.05 times 1.388888889 meters. So the answer is 1.45833333 meters. And to find the spacing from reflector to driven element, we need to times the 0.15 times the lambda, which is 0.15 times 2.77777778 meters, and the answer is 0.4166666667 meters.
Next up, we have the spacing from driven element to directors. In order to solve this, all we need to do is to multiply our wavelength by 0.10. And if we do this, our answer shall be 0.27777777778 meters. And for our number 8, we have the length of boom. And in order to solve our length of boom, all we need to do is to add our spacing from reflector and the spacing from our director to our driven element. And in addition to that, we need to add 0.0508 meters, which is equivalent to 1 inch. And if we do all of this, we get an answer of 0.7452 444444 meters. But all of this is just our theoretical values, since we need to subtract 6% to the theoretical value in order to get our actual values of the antenna. If we finish subtracting the 6% and manage to get our actual values, then we can move forth to our next step, the drawing. For our drawing part, we use a 2x3 tracing paper with a 0.5 lettering gari and a T-square to draw the image on the screen. We use the Pat's Form B paper for our inspiration for the borders, and this is the most hardest part for me. Since if you make a mistake when you are almost finished, then you either need to start again from the start or wipe the inks using other method. And that is it for our presentation. Thank you for listening on how we managed to calculate and design our antenna. Goodbye.